We're going to learn how to solve exponential and logarithmic equations. I want to remind you that one of the most important things in logarithms is how to go back and forth between exponentials and logs. So I'll just put that right there. Now I'm breaking up these equations into three types here. The first one, which are generally considered the easiest, are called, well, I call them common base exponential equations. And that's when you have an equation where both sides are using the same base. So in this first one here, I have 5 to the x plus 1 equals 5 to the 3x minus 4. Now, due to the fact that exponential functions are 1 to 1, that means if they have the same output, they have to have the same input. So 5 to one number equals 5 to another number. The only way for them to be equal is if they had the same exponent in the first place. So when you have a case like this, you can just take the exponents, set them equal to each other, and that has to be true. And then you just go ahead and solve things. So, I don't know, minus x plus 4. And I get 5 equals 2x divided by 2. And we get our value for x is 5/2. So whenever both sides of the equation have the same base and they are equal to each other, that means that the exponents have to be equal to each other. Now for part B here, I have 9 to the x equals 27 to the x minus 1. You might at first say that's not a common base equation because they don't have the same base, but we know that both 9 and 27 are powers of the number 3, so that means I can rewrite both sides to use 3 as a base instead. So 9 is 3 squared, and it was 9 to the x, so we have that. And 27 is 3 cubed, and it was raised to x minus 1, so we have that here. Now these parentheses are important because when you have an exponent and an exponent, you multiply them, and because it was 27 completely to the x minus 1, you multiply that 3 distributed into x minus 1, you're going to get 3x minus 3. And now we've converted the problem to have the same base. So now we can let the exponents equal each other. And we do a little bit of work here. I don't know, subtract 3x maybe. Divide by negative 1. And we get the value of x equal to 3. So common base ones, you don't have to do anything too fancy. Just once you've gotten them to have the same base, set the exponents equal, and you are done. You can completely avoid logarithms here. For the next one, we have what I call different base exponential equations. And the first one here, we have 2 to the x equals 17. Well, guess what? 2 and 17, there's no way to make them have the same base, so I can't do it. And what we're going to have to use is whenever we have a different base exponential equation, we will need logarithms. Now, if it's already in this nice format where you have a number to the x equals 7 and equals another number, you can just go straight to writing down logarithms. So remember, based on this rule up here, if you have 2 to the x equals 17, that means that log base 2 of 17 equals the exponent x. And although this looks weird, that in fact is the answer. You've solved for x, you found the value. Now, that's not a really nice number answer there, but if you want to, you could put it in your calculator to get a decimal. I will say that in math classes, we generally prefer leaving it like that. We don't like the decimal answer. The reason why is if you write it as a decimal, you're going to have to round because it goes on forever. And if you round, that means you are not giving me the exact perfect correct answer, only something that is close to the correct answer, also called an approximate answer. And the only way to give the true exact perfect answer is by writing it log base 2 17. So we prefer it written that way, and you should prefer it too because you can just leave it there. You're done. You don't have to do any more work here. Now for the next one, we have to be a little bit careful, because we have 4 times 3 to the x plus 1 equals 28. And the thing is that x plus 1 on the left, that's only the exponent of the 3. It's not the exponent of the 4. You also can't do the 4 times 3 is 12 because they have different exponents. So when you have a scenario like this, what you need to do is you need to get rid of any extraneous numbers in the front. You need it to be just a base to an exponent equals a number. And once you have that, you can use your logs here. So log base 3, 7 equals the exponent x plus 1. And then the last step would be to solve for x by subtracting 1. So log base 3, 7 minus 1. And that would be your answer. Now it turns out you can also solve logarithmic equations in a similar fashion. But instead of converting your exponent equation into logs, you're going to do the reverse here. However, it is using the same rule from the top up here. So if I want to solve log base 2x equal to negative 1, we're going to convert that. And we always say the base to the right side equals the inside. So 2 to the negative 1 equals the inside. And then that's it. X is 2 to the negative 1 power. If you prefer, 2 to the negative 1 is the same as 1/2. If you really prefer, you could put this as a decimal. And this time it's okay to put it as a decimal because you didn't have to round it or anything. And any one of those is a perfectly correct answer. Now on the second log one here, you might get confused at first because you don't see a base there. But you need to remember that when you have a log with no base, it is really a 10. And then we do our trick here. 10 raised to the 2 equals 3x minus 2. Well, 10 squared is 100. Add 2 to that. Divide by 3. And we get our value of x is 34. So again, a lot of log and exponential equations come down to knowing the formula of how to convert back and forth. As I said in the previous video, it's the #1 thing you should know about logarithms.